I'm Stephen Foskett, the organizer of the Tech Field Day event series. The video you're about to watch is part of the Storage Field Day presentations held in San Jose, California in October of 2016. We welcome Primary Data here. They've presented many times, and if you'd like to see more videos like this from Primary and other companies, you can go to our YouTube channel, youtube.com/techfieldday. If you'd like to learn more about the Tech Field Day event, just go to techfieldday.com.
So this is where we're actually going to do a couple demos now. And so the first one we're going to do is we're going to show you how easy it is to create these rules and objectives for automated promotion and demotion. And we're actually going to promote from NetApp to an x86 box with NVMe flash. So for purpose of promotion, we're going to get better performance by going to NVMe. And then we're going to show you a demotion where we're going to take that data from NetApp and demote it to S3 bucket in Amazon. Okay. So just so you guys can see, this is our UI. So this is DataSphere, right? And so there are many menus here in DataSphere. One is you can actually see the different storage that you have in your environment. So for example, if I select all, I could show you all the different types of storage that I have in my environment. And this is, so here I can see I have different Isilon systems. I've got different Amazon S3 buckets. I've got NetApp cluster mode. And I have what we call Dell DSX, which is basically our software on top of an x86 server with local NVMe flash. So what the industry would call SDS, basically. Okay. So you can see that in Primary Data, it's very easy to actually now aggregate all these different types of storage systems, and they would actually all show up here and give you a single centralized view. So instead of managing them one by one, you can say, hey, across all my storage systems, I've got 98 terabytes worth of capacity, and I'm using 8 terabytes right now. Okay. And obviously, this is a demo environment, so it's kind of small. So I'm going to go to here where you can get a file system view, and I'm going to click whoops. I am going to. Can you tell it's not my computer? I'm going to click on this file here, this webinar, this presentation. Right now, it's on AWS, and I want to move it somewhere else. I said, you know what? I need better performance. Now, in the real world, you would actually set the objective, and as IOPS increase or as latency increase, we'll automatically move it. But for the purpose of the demo, I'm going to manually force it. So I go here, and I said, OK, now I've got these different objectives created. And this one says Tier 1 x86 NVMe, which means move it to something that's fast, Tier 1 x86 NVMe. And that is now how we show a manual movement. And so what it's going to show for you is right now, the file is going to say, OK, you have now changed my objective. And so I am going to move to a different location. And it'll take a while to upload. It'll take a while to kind of refresh itself.
Can you see the rightmost column on that?
Yeah.
Is it not showing on the screen?
It doesn't show up my
The
screen.
compliance?
Yeah.
Scroll over.
Here we
There
go.
it is.
Oh,
Yeah.
there we go. OK. So you see this red circle, which means it's no longer compliant, because the original rule that I set was this data belongs on a slower storage system. And by changing it, what we're telling you is, hey, this storage system can no longer address the needs of your data. That's why you're getting a red circle, right? So you, as the administrator, can see, OK, I probably have a problem here. Now, you could choose to manually fix it, or you could allow us to automate the remediation for you. So here you see it's just turned green. So once it moved to a storage location that could actually address that objective, those needs, it will automatically turn green. You didn't have to do anything. Now I'm going to prove to you that it actually moved. So in our UI here,
That's pretty.
Uh-oh. Right? So what I have here is a destination and a source, right? And so the source is the lighter color, and the destination is the darker color. So what we have shown here is we moved data from cloud, PD Archive Cloud, to Dell NVMe. And if you don't believe me, I'll click on it. And it says, one file moved from Dell Cloud to NVMe. So you can actually see what actually happened. Now, obviously, in a real environment, you're going to have a lot of more files and a lot of different reasons for why you want to move. A manual move, are you moving for performance? Are you moving because you're out of capacity, which we call pressure? Are you moving for protection? Because I might have something on very fast SSD, but I only get 3 nines of availability, and I really need 5 nines of availability, so I'm going to move it there. Or I'm moving it for location, right? Hey, this is too far away. I need to make sure my team in India can access it. Please move it from LA to India. So we actually give you the ability to select which ones you want to show. So you can click it. You can say, I want to clear it all. And we have the ability to show you different ranges of time. You know, during 5 days, during 24 hours, what did you do to actually show all the different movements that happened? Okay. So that was pretty easy. I just showed a promotion with that. And again, normally in the real world, you would just simply set it, forget it, and as IOPS increase, it'll actually do the move. And how do we know? Well, because this is what an objective looks like. You have the ability to go in and create rules, saying, I want for this data this level of nines for durability, for availability, for protection, as well as from a performance perspective, you know, what my bandwidth, IOPS, and latency needs to be. You have the ability to set this, create it. Now, you don't have to know everything. I want to stress that. Out of the box, right, we can automate this for you. We'll have templates for you that it'll just happen. Or out of the box, we can make it so you don't need to have any of this. It'll just work.
Yes. And you can call it high, medium, and low performance.
Because
correct.
people want to be able to tweak that stuff.
Exactly, exactly. So what ends up happening is customers start with this, sort of these templates to get started with, and then their application team comes and goes, hey, that was pretty cool. I didn't know you could do that. Well, you know, I really need 50 megabytes of bandwidth, not 5. Well, I really need X, Y, Z. And then they can start getting more granular and say, oh, okay, I need it not just for this application, but just for these folders, just for these files, et cetera. So it gives you that level to customize. But that's what's happening behind the scenes. It's these objectives are setting the rules for why things need to be placed where and where.
What happens when you increase the availability number?
So we will go and say, now this data needs to be on a storage system that can have that level of availability.
Will you put it on more than one storage system?
Yes.
Yes.
And it's mirrored from the client, so we can do the spreading to maintain multiple synchronous copies.
So that's interesting. So because you make a point of saying that once you do the metadata lookup, right, now the client is talking native. Mm-hmm. What if the client doesn't have the capability to write to 2 at the same time?
Well, of course, we're presuming a client that is enhanced with all of the parallel features. And this is what we've pushed upstream in Linux and what the filter driver does on Windows and for ESX. So that's one of the big differences, is that we as a company have tackled the fact that clients fundamentally need to be moved into the modern era where they have telemetry, they have throttling, they have replication, all built in at the client level, so that you don't have to have intermediary boxes to do these things at the expense of having to bounce the data on and off of networks and through a separate bump in the wire.
Yeah, I'm trying to understand, and again, I seem to be asking the deep questions in the,
good.
in the shallow presentation.
You're asking the wrong guy. You make me jump up. That's fine. I don't mind.
But so I'm trying to understand. Let's say I just have a regular. I think I'm writing to a regular Linux NFS.
From the perspective of the client and all of that, you're just talking to an NFS namespace.
Right.
And that's our.
But now you're telling me I need to write that file to.
The DataSphere is what you point the client to.
Right.
DataSphere is what is your NAS thing. What you don't even see and are completely unaware of is that under the covers, DataSphere is negotiating with the client and handing him routes. Those are leased entities that can be recalled so that the routes can be changed dynamically. So it's like DNS in the sense that we've enhanced this client to do DNS lookups and get the routes and go straight to it and be able to be rerouted in the future in a way that's protected. It even includes fencing capabilities. In case a client is misbehaving, he can be fenced off so that he's sure not to have access when the routes change. So you don't have to wait for all of your clients to agree when you go to changing routes, because if somebody's delinquent and doesn't turn in their lease, you can fence them and everything. These are all parts that are built into the protocol that allow us to do
But is it
this
built
stuff.
into the protocol to have a client write to 2 NFS servers at the same time?
It wasn't originally, neither was the telemetry nor the throttling, and we had these things enhanced and added into the NFS standards body and into the NFS open source.
So it is now.
It is now. That's right.
You wouldn't know it because without primary data, you wouldn't
Clearly,
have
I
the
don't.
capability to
That's
access it, right?
So that's right. We're driving the
Yes.
technology that make it possible to do these things at the client where they should be done, so that you don't have to reroute the data downstream.
And so things like that is now built into the standard Linux and Windows clients?
In the
NFS?
in the standard Linux client, yes. In NFS, or sorry, in the Windows world, we have an agent that can load in the Windows box if you want it to do this natively. If you don't want to muck with it, you can always go through a portal, which is a DSX node, that supports standard SMB and standard NFS.
Okay.
So we really have two modes. If you don't want to muck with your clients, you're probably not interested in the highest performance, in which case you can go through an intermediary and you're no worse than the rest of the world with all their layers of intermediaries, right? But if you do want to get ultra high performance, then you can have the latest and greatest client, the Linux upstream client that has all these capabilities, or drop in the filter driver in Windows and get your control and data plane split at the point of origin of your I/O and get all of the wonderful benefits.
Okay.
Thank you, David. So
Fascinating.
now we're going to actually go and show you the archive to cloud. So for example, we have an objective that says, hey, when something gets inactive, please move it to object storage, or in this case, we pick cloud. So once I change the objective here, again, it's going to go through and it's going to say, okay, I am going to now assess and say, hey, I don't need to be on tier 1 NVMe anymore, which is why it's red. I actually need to be on something for object storage, which is going to probably give me better availability, better, et cetera, as well as a lower cost. And that's why you see this red. So we're computing, we're letting you know that a decision has been made where your current storage doesn't fit your data needs, and an action needs to be taken, hence the action is moving. And so we'll actually now do it. It's finished making the change, it's finished making the move, or it will. Takes a bit to do that, but once it does that, we'll again be able to see in the mobility chart as well. Right? So now you see there's two graphs. It's light color, unfortunately. It's going to show well on the projector, but before there was one. But now you have two, because earlier we did one for promotion. So now you can see two. You can click on it, and we'll show you, for example, hey, I actually moved this from archive to DSX. Hey, this one I actually moved from DSX back to archive. So again, this is a very quick demonstration to show how easy it is if you wanted to manually change the objectives or the rules which govern the tiering or the movement. Most of the time, it's going to be automated for you. So you're not really going to have to do that. Last demo, just very quickly, and this is obviously not our UI, but this is Isilon. But it's just basically to show you, for example, with Isilon, for the most part, each client can only talk to one node, right? If you're familiar with the Isilon UI, it'll tell you which client is mapped to which particular storage node, and it's usually a single mapping, right? And if you look at what I did was I put in the IP for DataSphere. And so now with DataSphere, it actually shows that in this 3-node cluster, DataSphere can now access all 3 nodes. And this is how we get the improvement in throughput and the improvement in IOPS, because we can now parallel stream to all the nodes concurrently, as opposed to having one single NFS mount point as the bottleneck.
That's a nice way to summarize it. The client can talk to all the gateways as opposed to just a single gateway.
Yep.